So let's attempt this GOC's interview series contest. This is a great initiative. Let's see. I'm a bit rusty on these interview problems, but I hope I should be able to do these. So I'll be recording it, and I'll try to explain the things as I code the problems. So is n greater than equal to 1? Okay. Okay. So n equal to 0. So since you can have the same element, we have like, and then you have to maintain the best. So let's use long because the values can be pretty large. So answer will always be 0, at least greater than equal to 0. So for mini will be minus, say, 1e, sorry, 3e8, 3e9, because elements will be greater than that, and we have mini equal to max. So we maintain the minimum value of the all possible things that we have seen till now, right? So we have like a minimum of whatever the initial mini was, and then the current value, that is ARR of I. Okay, so you have the input and output. So n scene and ARR of n for I equals 0 plus scene ARR of, and answer equal to max of answer comma ARR of I minus mini. That should, if we see out the answer, that should give us the desired output, I guess. Let's not wait for this one. Compile time error. Okay, fine. So let's have everything in LLI. That should be good enough. Okay. If we submit this code, let's try and submit this. Okay. This is like a kind of a sweep line kind of thing. So okay, so let's see. Okay, this passes. So let's move to the next one. This will be okay, and you have queries, and so we will pre-compute all the answers for all the positions. So let's do that. And see, and so you have the values. So let's take the value. So the value part is done. So what is the answer for this, right? So answer for 1 is 0. That means you need no jump. So we want answers for all the cells from 0 to n minus 1. So okay. Now so where was it till which we could use, and the max reach is equal to, okay, that's not right. Max reach is equal to up to, you can reach up to 0. In fact, if you can reach up to ARR of I, so is it guaranteed that you can reach every cell? Yeah, every cell is greater than 1, so you can reach any cell if you want. Okay, so max reach is ARR of I, ARR of 0, in fact, the first cell wherever you can reach. So okay, so take the max reach as equal to the max of wherever you could reach till now, comma, whatever position you are at, that's ARR pause, right? And then for feature I, so you can reach up to this, and then from this cell, and obviously the answer for 0th position will be equal to 1, equal to 0, because that's the first cell. And then from that pause to this many cell, what you can do is that so wherever you could reach at max, you update the positions up to that max reach. Okay, so that would be max reach. Okay, max reach up to this much position you can reach. So are we jumping exactly 2 steps? Fifth stone plus 3, right? So you can reach up to the value that is pointed over here, and you take the minimum of that with n minus 1, because you don't want to go beyond n minus 1. So you do answer of I equal to last plus. So what you do is that you do last plus plus, because you now use one more steps, and then the answer for up to that position will be equal to last, and you update pause is equal to max of. You are done up to max reach plus 1, like from there you will start, and then by decrementing 1 we will like, so we will also need a variable like temp, because we want to store up to how much we are storing. So everything is integer in this. So now we just answer the queries. I think this should be good enough. At integer x, c x, c out, just the answer of x minus 1. We need one extra each answer in separate lines. That should be good. I'm sure if this max parts are good. Okay. That's weird. Okay, so you have this return 0. That's why. Do we need a return 0 in this one actually? Like, sure. Okay, the page seems not to work. Network in West Bengal is very bad. Each jump moves up by high and moves up, Nandu moves up by B. Okay. Is it that simple? Okay. Okay. You are given test cases, right? So what is the order? XAP. Okay. So we need long because or else it's not gonna work. So let's not keep any ends because anyways the answer is going to be long. So we just need the LCA of A on B and that is equal to return A by GCD of A comma B into B, right? So that's the LCM and I hope they are not zeros, right? Yeah. XAB this should be the formula, I guess. I have not read it wrong. Okay. Segmentation fault. Okay, that's weird. And Q. That means we are accessing some sort of out of bound thing. Max reaches up to thing. Okay. So let's make answer 500500 and well, 5005. That should do the trick. A row of Count the number of distinct bricks painted by. Okay, let's see into the tutorial what they mean. Total number of distinct bricks are. Okay, so whichever had at least once painted, right? That's what the question means. So do they have test cases? Okay, so m is equal to uh, m bricks in n days. So anyways, the points that are over here only matters. So we just need those. So what we do is that we kind of compress the space. Let's check into this. But this work. This as well. Okay. So now this, and this remains. And let's complete this one first. First, we have given n and m. Okay, m is fixed. So you kind of have a vector which is very large, so you cannot like create a prefix some kind of thing for this. So you use something called coordinate compression. So for coordinate compression, what you do is that you first of all save the ranges that are given to you. So L and R are given to you. So you take L and R, you push them back at the end of like. So I'm using in place back. That's a bit faster than that. So that I can use this, and just for making the thing work, I'm gonna use this. That because I'm gonna need these points like a prefix sum. So I'm just gonna pushing them into the map without any value. Like they will be initialized to 0 by default, and then now for auto v in MP, you basically have those points. So you basically just number them in increasing order so that you like have a vector kind of thing, and then you can create an array. Is it even required? No, right? Total 10 distinct total 10 distinct bricks numbered this. So from 7 to 10, because after 7 there was just this 10, and then there was 12, 13, 14. So 12, 13, 14 are painted. So like even if they are same colored, they are not counted different, right? So why are they written distinct? I'm not sure, but okay. That means you need to find the union of the ranges. That's the problem, I guess. So for that, you just add this to this, and then, or else you don't even need to compress the thing. Let's code it a bit more in a simpler way, maybe. Okay, let's code it in a bit simpler way. Let's sort the array. And then form starting from begin. Okay, so this should be end. This is how you iterate. So if ARR of I dot second is equal to 1, that means we are increasing thing, right? So so let's distinguish first on the basis of whether we have something as opened or not. If count is 0, then it's obviously a starting point. So we mark that as start of ARR equal to of I dot first, and you just, so we have guaranteed L is less than equal to R, so you just increase count because this has to be L, or else count plus equal to ARR of I dot second. If count is equal to 0, that means something has been closed, like everything is done over here. So we just add things from the previous point till this point, so that's stored in the start. So answer plus equals to um, that ARR of I dot first minus start, and those many distinct points will be added to the answer, and we need an answer as well, right? And since m is less than equal to this should hold well in an integer variable as well. So let's see if this works. Pretty sure. Okay, so this is like a sweep line technique that you put +1 at r, and r minus r plus at r plus 1 you put, okay, I is less than ARR dot size. Fine. The map was not declared. We don't need the map. Okay. So we don't have the bits std++ imported. Okay, that's why. So we had to include bits std++ if we wanted to use map. So compilation errors are okay because that's not a problem. You just had to typecast it to integer to make it work without a error. Let's read this one first. That worked. Let's see these two problems left. CS has finally managed to become a class monitor for them. That line is written as an order. So after, also the girls, after only swapping the positions among themselves, and okay. AI is congruent to BI mod 2. BI is less than equal to what? Really unclear. Let's move to the next one. After all those hardship of the CDC, flag it is just this. Rectangular window frame. Okay. Okay. So you have kind of like noticing the same pair of rods. Nice. So this is doable by like combining the pairs at first and then working on that. Let me quickly read out this problem. Really weird. Isn't the okay? So it's not working. If I manage to become the fast multiple sections, first to turn out to be extremely cleaning. We arrives for assembly, but notices the line isn't in ascending order. So only the girls will. Also, the girls will only swap positions among themselves, boys, and all boys have the even heights and all girls have odd heights. Help him find the best possible order given the constraints. Okay, so you basically have all the positions which are odd in one set. This, and this, and this, and you sort them in their increasing the sets, right? Okay, so we don't want to use a I will code it over here itself. So we just want the positions. So vector teachers was 2 and vector of integer value of 2, so that will mark the so integer n scene and int arr of n for integer I equal to 0, I is less than n, I plus plus scene arr of I, right? Now you need a answer, so we're gonna use this later on, answer of n, because we need to replace them obviously, and for integer I equal to 0, I is less than n, I plus plus. So we put val of arr of I and 2, so that means the parity into the place of arr of I, and we put in position I, right? Now we sort arr of 0 dot begin, arr of 0 dot end. So I'll be explaining the problems after the contest. Not great at explaining things while I'm coding them. So we don't need ARR. We in fact need the values to be sorted in their respective sets. That's why we are doing this. And then we just use the values for integer. For integer I equal to 0, I is less than val of 0 dot size I plus plus. So answer of position of I is equal to value of I. Value of 0 comma I, right? And position of 0 comma I, that's the thing. And similarly, so we can nest them in one another loop that this thing can be done just without writing it twice, that you can use this as j and this will be j and this will be j, so that works well. You just now then you need to print the answer, right? So for integer I equal to 0, I is less than n plus plus cout answer of I think that should work. Okay, so EB is like emplace back. I tend to use a sort notation for things. That's why this practice makes me do this mistakes, but I think that's okay, right? Okay, just start putting 6. Am I putting out answer of I? Okay, let's look into it. Your end. So in the problem, okay, in the problem are you given test cases? Okay, that's why. Okay. So all these things will be inside each test cases, and after each test case, you just like do this, right? This should work, I guess. Yeah, that's passes the test cases. Let's move into the next one. So it's like you need to find the sum of those which are, if I work on the kind of like a sorted values, that should work, right? Okay. So you just need the count of numbers which are less than equal to some particular value. Because so it's like how many elements can you pair with this set? And the thing is, okay. So since everything is pretty large, let's use n and s. Okay. So you have the n and s given to you, and then you have the vector of size n. So you take that. Okay. And from that you could easily do kind of like a sort on the array, right? You could sort the array, and now for every pair you like have the count, right? So now, okay, so you just keep a answer variable to keep track of the answer, and answer plus equal to lower bound. So we want number of elements less than equal to some particular value, so we will use upper bound, arr dot begin, arr dot begin plus I, because we don't want to consider I element, so it's not going to pair with itself, and you can use a value up to this, right? Because that's the maximum value, or else the value will exceed s, strictly less than it or exactly equal to s. So output a single integer number of possible rectangular frames that can be, okay, what is this area? Okay, less than equal to a, right? Should not be more than a. Okay, fine. So it's less than equal to, so that should be okay. And with this we just subtract arr dot begin, that should work like charm. Let's see. The test case. Okay, that solves all the problems, I guess. Am I left with any problem? I don't know. Hmm. Hmm. So the network is not that great in West Bengal. That's a big problem nowadays, but still, let's see if we can work with this or not. So I will try to explain the ideas of the problems so that maybe you can code after the contest. This was a nice contest. Like, this is the actual, this is like a medium level coding round test that generally comes in CDC, and this is quite accurate, in fact. Okay. Mhm. So let me quickly make the explanation video that will make things much more clear, I guess. So I hope you guys like enjoyed seeing me coding if you're watching this. Okay, so we have a lot of participation. People in KGP are becoming active. That's great. So this is like the actual difficulty level that is seen in actual coding round. So all these I felt that all these problems are like equally worthy for of coming in any coding round, and in fact some problems even difficult than this come in coding rounds. So you should basically prepare at least at this level or maybe more than this. So let's see how you solve or tackle these problems. We'll try to quickly describe the ideas because I don't think discussing much on these would help. So the first problem is pretty much straightforward. That okay, let me quickly open up all the tabs. That should help because my network is not supporting me at all. Okay. So you have n elements and like you need to select two indices such that j minus ai is maximum, right? So if you want to have this as maximum, one thing that you can do is that you for every j, so we are basically iterating on every j possible, and for every j you find out a previous ai such that this quantity is maximum. Now if you want this to be maximum, since we're iterating on aj is fixed, right? So we need to find the ai such that this will become maximum, and that ai is nothing but the minimum that you have seen till now. So you just maintain a running minimum. So they don't show me my own submissions. That's weird. So for this problem, you can like, so let's, so this is, I hope, explained that you just maintain a running minimum of values like that you have seen. So since all elements is less than 2 into 10 to the power 9, I've taken initially it as 3 into 10 to the power 9. And for every element you iterate on, you just keep a minimum of all those. And like for every element, you take that value as aj, and you take the best ai possible, and this quantity will be maximum when the ai taken is minimum, right? So you just subtract the minimum value that you have seen till now and take the max of all such, and that's your answer, right? So that's how you can solve this one. Let's move to the next one. This one was pretty easy also. So let me quickly maybe, so this is pretty simple that you have like a, you're at like some particular level, and then you are at some height x, and from here one person starts jumping at a step length of a, right? And someone starts jumping at step length of b. So we know that a sequence that jumps like at distance of a, and something that jumps at distance of b meets for the first time at the point where the value such at such a value which is both divisible by a and b, right? And the least such value is nothing but LCM of a comma b, right? So from this height you meet at a point which is at a distance of LCM of a comma b. So the total height of that position will be LCM of a comma b plus x. And let's see in the code how that can be implemented. Straightforward, I feel that you have a GCD, you can easily create a GCD function. This one, you can easily create a GCD function, and LCM is nothing but a, LCM into GCD is equal to a into b. So you can use that to find out the GCD. This should have been kept a bit earlier because this was much more easier question. But in so this is like a good thing that you should look into all the problems in contest, because the questions are not really ordered in coding rounds. So you just have x a b and then find x plus LCM into x plus LCM of a and b. That's it. And LCM is nothing but a into B by GCD. Now since GCD obviously divides A, so that's why I'm dividing it before multiplying. So that makes things much more easier. Okay. And this is the standard GCD function. So let's keep a track of this. Sure. Yeah, people have solved it, solved all the problems. So these are pretty standard, and you should be able to solve all of them if we give the time for at least 5 hours. So now in this login pawn, you're given like queries for positions, and for each position you're given queries to find out what is the minimum number of moves needed to reach from the first position to some cell. Okay. Now in that, if you see it that way, you cannot like handle each of the queries in alone, because that would take you order and time. So you have to like create answer for all of them together. Okay. So for that, what we can do is that this as well. So this one is clear, I hope. It's pretty simple. This one is a good problem. So in this one, what you can do is that let's suppose you have, okay, let me, okay. So now suppose you are at some position I. Suppose there are a lot more cells previously, and you could come to this cell with some steps 3, right? And the value at this cell is 4. Like from this, you can reach to 1, 2. If I don't draw them, 3, 4. Like you can go to all these cells with just one jump. That is the power that is given at each cell in the problem. So basically, if this is 3, all this will definitely be less than equal to 4, because if this is 3, you can jump from here to in one to these cells in one step, and so the distance to these all will be less than equal to 4, right? So in that case, you just maintain a minimum for all these segments. So so one observation that you need in this problem is that the final array of minimum distances, like this is an array which contains say minimum distance from 0 to I. Okay, so from 0 to 0 will be 0. Now 0 to 1, 2, 3, these will at least take one step. Then suppose you need 2 steps to reach 3 and 4, and then beyond that you need 3 steps, and so on. What you will see is that this array is actually monotonic, right? That you first have 0, then a bunch of 1s, then bunch of 2s, and then bunch of 3s, because you cannot have like bunch of 1s, then bunch of 2s, and then bunch of 1s, because if you could reach these cells in one 2 cell, you could not reach these in 2. You could never reach this one in like one step, right? Or else these would have been covered, because the ranges given in the problem are actually continuous. So this will be a kind of a monotonic. So you could maintain some kind of like, for all the cells that are marked 0, you maintain a range of positions which will be marked 1. Then you mark them 1 and take a maximum of all the cells that you can reach from these cells, and mark all those cells as 2. Now from all these 2's, you can take the maximum cell where you can reach, like suppose up to this cell. Then you can mark all these cells as 3, right? So you can do this, and in this way you can like find out the minimum distance to any particular I, this whole array, in order and traversal. And once you have this array, you can easily find out the answer for any query in like order 1, right? So in this case, yeah. So let's have a look at the code. So my network is a bit laggy, but oh, okay. So till the net comes, let me explain this problem. This is also an easy one. So basically, you are given that there are a bunch of boys and girls, and boys have height of odd, and girls have height of even. So and girls can switch places in between among girls only, and boys can switch in between boys' places as only. So given this constraint, you need to find out the best possible sorted array that you can form. Okay. So it's like you have these cells, and like this is a boy, this is a boy, this is a boy, and this is a boy. So you basically take the best possible order among boys and best possible order among girls, and then overlay them back in the same order, in the same positions they were. Like all the positions that were initially girl only will remain girl only, right? After, even after the switching. So that should hold. So let's see how we code that one. So this is, so for this problem, what you can do is that you can kind of have, okay, so in this one you can do is that suppose you have the array given, right? And suppose this is your ARR array given as in the input that has the values. Okay, so suppose this is 2 3 2 um, 9 1 4. Okay, so so let's extract out the positions, because the positions will remain same for the boys and the girls. Like boys, so all the positions which had boys earlier will have boys, and whichever had girls will have girls. So 1 3 and 4 will have whatever odd parity numbers have, so these will remain odd, and uh, 0 2 and 5 will remain even, right? So this has to happen, this has to hold even after the swapping that we do. And after the swapping, what you can do, what you will have is that among all the odds the things will be sorted, because that's what they want in the problem. So you take all the odds, one, so the odds are 3 9 1, right? And then you sort it, 1 3 9. Similarly, you have the evens, 2 2 4, and it's already sorted, so it doesn't affect anything. Now you place these values into these positions after sorting, and you place these values into these positions after sorting, and that should do the trick. So that's what even I have implemented in my code. So, so that's how this was supposed to solve. For this one, what you can have is you're given a L to R segment that you need to color, right? From L to R, you need to color them some color, right? And the only thing that it had in this problem was that this M was given pretty large, so you could not use some kind of prefix sum on arrays. So in order to tackle that, what you can do is that you just keep the ranges. Okay, so you're given like 2 to 5, then 10 to 10, then 4 to 5, then 3 to 7, then 12 to 4, right? So in that case, what we have is you take the union of all these ranges given, like 10 to 10 includes the point 10, right? You have the elements at the point, so you take the union of all these points, and the total length of the union, total number of points covered by the union, will actually be the answer for this problem. Okay, so that's what the question actually means. So now the question is, how do you find a union of a bunch of given ranges, right? This is a problem in itself, like this is a standard problem in itself. Let's see how you solve this one. So I hope this problem is clear, that how you like sort all the events separately, all the odds separately, and then place them back at the positions they were originally in the input array. And if you just place them back in these positions, you are done. Like you place back, so, the final array will have something like a six, will be a 6 element thing, and you will place 1 3 9 in positions 1 3 4, 1 3 9, right? And then you place 2 2 4 in 0 2 4 5 positions, like this order, and this is your final answer, right? This was what you had to do in this problem. So till then I will explain the next one. So this is done. I'm waiting for the net to come so that I can explain the code once. I hope the logic is clear for that one. For the problem montation bricks, this, as explained, is like a union of the ranges. Now we will look how we can find the union of ranges pretty fast. Okay? So we can look into that as well. Let's see. So let's see. Suppose you are given a sort of, in this, suppose you are given a range from 2 to 4 and you're given a range 3 to 5. The idea that I've used is that you can do a plus 1 at 2, minus 1 at 5 for this range. For this range, you can do a plus 1 at 3, a minus 1 at 6. What does this mean? That you are adding a range contribution from 2 and beyond, and you are subtracting one from for the range 5 and beyond. So you will see that if you do this will boil down to be a plus 1 in the range from 2 to 4, and then beyond that all the arrays, all the positions in this array will get 0. So this technique is something called as a partial sum. So that is the basic idea for this one, that you maintain kind of like a sum of how many ranges have been activated till now. So what you do is that you take all the ranges as L and R, and you do a plus 1 at L and a minus 1 at R plus 1. This is what you do for all the ranges, right? And then you just sort the values. You just sort all the ranges together by putting them into a vector and then just sorting them. After doing that, what you can do is that just start from the beginning. So let's take an example, and that should like explain how is it working. So in this case, if you sort them, you will get a 2 comma plus 1, 3 comma plus 1, 4 comma minus 1, 5 comma minus 1, and a 6 comma minus 1, right? Like this is how we are doing the thing. And you sort it, so it gets sorted by these values, right? So now, uh, after you're done with sorting, what you can do is that you can start taking a sum of elements from the start. Like if you take, suppose you maintain a running counter count equal to 0, okay, and then you start from the front. If you see a element with a plus 1, you mark this as the starting of the range. Like you have marked the starting as 2, and you start increasing the counter. Like you are in a some kind of union of ranges now. Like you have started from somewhere, right? Now the points will get counted. So now when you come to 3, it is again a plus 1. So counter just increases to 2 because there is a plus 1. Now you come to 5. Now this is minus 1. So counter gets decreases by minus 1, which is equal to 1. Now when you come to 6, counter gets decreased again, and it gets to 0. Now when it gets to 0, that means all the ranges are like now not contributing to the answer. So the point where you got a minus 1, where you got the last minus 1, this 6, is like the end of the union for the elements till now. So you have like a union from say 2 to 6, 2 to 6, and for our cases, since we are doing minus 1 at R plus 1, this 6 will not be included and 2 will be included because we are including L in the range, because L is plus 1 and R plus 1 is minus 1, so R6 is not included. So in this way, this is the union of the range that is needed. Now, if you want to find the length, that is what is asked in the problem. Like you have to find the number of distinct blocks. What you can do is that you can do simply 6 minus 2, and that is equal to 4. And you can see that there are in fact say 4 points, 2, 3, 4, 5, right? These are the 4 points that you need. So that's how you can solve this problem. Just for every L and R, put them as a pair in a vector with L as plus 1 and R as and at r plus 1 you put minus 1 and put it into a vector and sort them. Okay, and now just do the thing where you maintain a running counter. Now this running counter technique is very useful in a lot of problems where you suppose need to find union of segments. You need to find intersection of segments. So it's helpful in both of them because whenever count is greater than 1, greater than 0, that means you are in some kind of union, right? And whenever the count is equal to n, that means you are in intersection of all the n ranges, right? That's how you can even find intersections of ranges, right? So this technique is useful in a lot of segments kind of problem where you have like unions or intersections or some property maintenance of segments. So this is like a general technique that you can use in a lot of problems. So in frog and pond, okay, so this was that monotonous 0 1s problem. So I can explain you the code one. So basically, the size of the array is taken and the array is taken. Now answer for 0 is 0, and this pause means from which position you want your next values will start. So from 1, your next value will be 1. That is maintained by last. Like now, since last increases, the last will now point to 1, and you maintain a maximum reach of the value still, like the of the current value. Like what is the maximum reach you can do using the values 1, using number of jumps 1. So you update all those positions and move your position to reach plus 1 because you have already updated this position as 1 and now you want to update positions with 2. So there you go. That should work. I think this is clear. And now once you have this answer array where you save in all the last, like the answers in the 0 to I, what is the minimum number of jumps needed from 0 to I, then you can like have simply query for, you can take in input the queries and just answer using the answer array, right? That's pretty simple. For the assembly one, let's try to reconnect this one. So this one is done. Let's look into the code of this one as well. So that, yeah. Okay. So you're already given pairs. The question might have been made a bit interesting by not telling that they are pairs. Rather, uh, the values, you need to do some kind of choose and all. Like you can make problems interesting this way. But anyways, you are given the pairs and you had to use a pair as one of the sides. So let's discuss this one after we have looked into the code. So yeah, so the code's opening now. So in that position problem, you just take the positions. Now this ARR of I and 1 gives you 0 if it's even, gives 1 if it's odd. So you just maintain the values of odd and the positions of odd. You maintain the values of even, the positions of even. That's it. Then you sort the values of odds, of the odds of the evens, and then you place them back in the same in the positions they were initially there. That's it. That should do the work. And for the Mahesh and bricks, you take L and R, you do a plus 1 at L and a minus 1 at R, and then you sort it. Then you keep a start, like where is the start of the current, the first time where the segment becomes plus 1, like the count increases from 0 to 1, that's the start. And you maintain kind of like a count of number of segments that have been activated. Like the count is like a prefix sum of this plus 1 or minus 1. Okay. So you just, if the count is 0, that means obviously the next one will be a L. So that's why you just increase count and mark it as the start, or else you update it with the second. And if it becomes 0, that means like you have closed all the unions and now you have like a particular union and you will get a answer over here, right? So that will do it. So all the test cases did get answered. So That's this one. Now we are left with the last problem, I guess. Yeah, a lot of people have solved all the problems. Okay. So in this problem, you're given nothing but this rectangular frames, and for every, so you basically just sort the values, and you need to find out the pairs such that the multiplication of these values don't exceed your the given area, right? Because the area of rectangle is nothing but length into breadth, right? Now, in that case, what you can do is that, let's say, once you sort, you get a lot of values x, y, and z, right? Now, these are sorted in value, and a pair will be accepted if suppose x into y, x into y is, sorry, the pair x and y will be accepted in the solution if x into y is less than equal to s, right? So what we do is that we kind of like iterate on the second element, like out of the pairs that will be selected, we iterate on this larger pair and find out the number of smaller pairs that satisfy. Now the important observation over here is that this set of smaller pairs will actually form a prefix, right? Because suppose you have like 1 2 3 4, and you suppose support up to, like, say you want the area to be less than 9. Okay? Area is less than equal to 9. So if you allow that, what happens is that this 4 will start with from 1. So 4 and 1 will satisfy, 4 and 2 will satisfy, because 4 into 1 and 4 into 2 are both less than equal to 9, and 4 into 3 will not satisfy. So you see that out of this array, a bunch of prefix will satisfy, and then again a lot of elements will not satisfy the condition, right? So you can binary search the point up to which the product of elements are less than equal to 9. So what you can do, so suppose x into y is less than equal to the given area, right? If that is something to be hold, so you know, so this is x, this is y, so you know y, right? So you can find that x has to be less than equal to the floor of x by y, right? Because x has to be an integer that's given in the problem, so it has to hold this condition. So you just find the number of elements in the prefix in the part before this element that satisfy this condition, right? If you can find out the count of such elements, that then you are done. Like, so every pair will be considered only once if you count it this way, because you're iterating on the larger element of the pair, and you are adding out the contributions. So so that's all the idea. So you basically use so in a sorted array, if you want to find the number of elements less than equal to x, what you do is that you do upper bound x minus, like a, the array a and x minus a dot begin. That's what you do. Now one more thing, you should not do a dot begin comma a dot end comma x, because that will not satisfy the condition. But instead you should do that a comma begin plus I, because if you are at some index I, you don't want to consider the elements that are beyond this, right? Like with I, the elements beyond I might also satisfy, right? Like up to this position, let's say. So you only want to consider the pairs that are formed that you have not seen till now. Like with with the elements which you have already seen. Like you only want the smaller value to be the ith index, not the smaller one. You want the larger one to be the I. So in that case, you should like only binary search on the prefix part of the thing. So that's how you just code this. Let me quickly show you the code for this one. Yeah. So you have NNS, you have the array, you take in all the elements and you sort the values, right? And then you take answer equal to 0, right? And this is basically the count of pairs. Now for every index that you go on, right? This is the so ith index. So when you are at ith index, you are basically counting the number of pairs such that the larger element of the pair is the element at I. So you binary search the array from 0th index to up to the ith index, not included. Like this is the syntax for binary searching a prefix of the segment. Like the ith index is not included in this case, and you search all the elements that is less than equal to s by arr of I, and you just add the count to that this, and you just print out the answer. That should solve your problems. I think that's all for this problems. I think all the problems are now discussed, right? So, as a quick review, this is like a nice attempt by the GOC team of creating a contest that are held by held for the internship and placement, because you should practice at least at this level to be able to solve problems in coding rounds at least, because the questions in coding rounds are at least of this level or even sometimes are tougher than this. So do practice a bit more. So the playing with arrays was let me quickly go through the problems once more so that sure that I've not left any one of them. So especially this problem of frog in pond and this Mahesh bricks and dream internship, these are like pretty standard problem and comes in like similar problems comes in a lot of coding rounds. So you should be familiar with these techniques. And I hope the questions were clear. And so this was a honest try to solve the problems. I hope you like the explanations. So do participate in all the contests for sure.